Okay, so welcome back to representing work graphically, or how to read work graphs. Now, like other quantities, work can be represented graphically, and we usually do this by looking at force versus displacement graphs. And when we write it like this, right, force versus displacement, we mean to say that displacement is on the x-axis as the independent variable, and that force is on the y-axis. So for force displacement graphs, the area under graph is what equals the work done on the object. And so if I have a complex graph like this, what I like to do is I like to separate it into as many readable shapes as I can, and I'll kind of color coordinate this. So let's say I got a force, again on the y-axis with the displacement on the x-axis here. And so I could see that my first shape over here is a rectangle. And so that'll be my shape number 1. My triangle over here will be the shape number 2. And then, of course, the other rectangle would be shape number 3. So I'm going to get the area for each shape. So for the first one over here, we're going to write area 1. That's going to equal to length times width, since it's a triangle, or sorry, a rectangle. And so we have 4 times 2, and that gives us a value of 8. For the second triangle, or for the second shape, which is a triangle, we're going to go base times height divided by 2. The base goes from 2 to 4. Now, of course, this graph is not to scale. I can see that here. So we're just going to assume that this number over here is roughly 4. So the base goes from 2 to 4, and that's about 2. And then the height is going to be from here to here, so from 4 to 6. So that's also going to be 2. That's going to give us 4. And then we're going to divide that by 2, which gives us an area of 2. And then finally, we're going to do a third area here, which is a rectangle again, which looks like it goes from 0 to 4. So length times width, where it's going to be 4 times 2. And I know it looks different than this one over here, but again, that's because we didn't do it to scale. Okay, so this is also going to be 8. So for the work done on the object, we just add up all areas. And so that'll just be 8 plus 2 plus 8. And that gives us a total of 18 joules for the work done on the object.